Okay, so for part B, now we're choosing point 2 from point 2 to 3 because we have everything for point 2 as well. Okay, that's you can choose this way or you can choose it from 1 to 3. Either way should work as long as you do it right. And so we are trying to find the speed at the at point 3, right? That's what we are trying to get. But we know now what the speed at v2 is from part A. Okay, so again, we just chose our points 2 to 3. That's step 0, and step 1 is writing the energy conservation equation and then simplifying it. So from 2 to 3, we don't have spring, and we are explaining here and then taking it to 0. And next is change in internal energy. Again, there's no change in pressure or temperature, and that's why it's 0. And the heat, there's no heat transfer. So there is a change in velocity, and there is a change in elevation, and that's why we are keeping them. And work term is the next thing to investigate. First, we need a free body diagram, and again, we are doing this for free body diagram is for between point 2 and 3, somewhere in the middle, not in terms like not necessarily middle, but somewhere in between. Okay, don't choose point those specific points. Okay, so we have this equation. Now we have two forces, weight force and normal force only, and the work term has two parts. Again, work done by the weight force taken or accounted as delta UG, so we're going to cross that out. And the normal force is also perpendicular to the displacement once again, as the displacement this way. So again, work done by the weight force is doing work, but we are considering it as change in potential energy, especially in chapter 8. We will focus more on the energy than the work, but you have to think about and decide. Either way is fine though, okay? So if you simplify it, all those terms go to 0. There's no work term either. Delta K plus delta UG is 0. Now you expand it. Again, this is delta K, this is delta UG. Final minus initial. Final is 0.3, initial is 2, so 3 minus 2, and you're writing them in terms of the energies we are given, and again simplify them. Since for part B we said that the bottom 0.3 has is the origin and upward is positive for the potential energy, gravitational potential energy. So that's why we are saying that this is 0, y3 is 0. That's the explanation. So we have three terms left. Again, be careful with the signs. K2 and UG2 has negative signs, and we are showing them here. Applying their definition, 1/2 mv squared for K, mgy for UG. And again, since this time every term has mass, just get rid of them, okay? If you plug the numbers in, you're doing more work. That's why I'm asking you to kind of hold on to that, simplify it, and then plug the numbers once, because sometimes we make stupid mistakes when we plug numbers in, and if you don't do it right away, you are going to reduce your mistakes as well, and you're going to save time too. Okay, so as usual, we are going to multiply by 2. Let's get rid of all those 1/2s, and these 2 are going to go away. Then the only thing left on the first term is v3 squared, so we have it here, and minus v2 squared, put it on the other side, becomes positive on the other side, and we have only minus gy2 left, and put that on the other side as well, and that becomes positive as well. And this is the equation we get here. And so next, again, let's just figure out how to find v3. Take the square root of both sides, right? But the thing is, we don't know y2. Instead, we are given that d, 1 meters. So doing a quick triangle, I just want to one more time emphasize where this triangle is. I'm going to go up to the figure. This triangle is between 1 and 2. So it's really, so I'm kind of moving my 0.3 all the way to the bottom. So we are having this triangle here. Okay, so this is d 1 meters, and this is y 2 because y3 is 0 and this is the same angle. So this is the, as you can see it here, this is the triangle we have, okay? So 1 meters and y2 are needs to be related. So then we use once again sine function because it's opposite over hypo. So then you can find out what y2 is and plug it in there right here. Once again, make sure to check your units. Okay, it becomes meters square per second square in the square root, so it comes out as meters per second. Okay, yeah, so the V3 is 4.19 meters, and that is the answer for the velocity 3 at the bottom. As expected, V3 is larger than V2. V2 was 2.40, right, because it's going to speed up when it goes down because there's the weight force component that kind of pulls it downward. Okay, again, you can also do the part B from 1 to 3, but there's also spring force. Spring force is going to be only for the amount of x. It's not going to be from x plus d. Okay, so be careful with that. But I would give it a try if you have time. Also, try to solve part B from 1 to 3. So your free body diagram is going to look more like this, like part A, because you will have Fs for the partial path. And that means you just need to take Fs for x for the stretch amount. So you're not going to use d in that equation, okay? But it's a nice practice. So I hope you try it and then find out the same answer that way. Okay, I think that's it about this problem.